recording. Okay, guys, I've started recording. So before everyone joined, I was just having a very short conversation with Mundia, who's one of our instructors. Let me share the screen. Who's one of the instructors that are going to teach us how to design a structure of his choice. So Mundia, take it. Before we start, share some of the things that we're discussing.
Okay, yeah, I was considering that since we've been doing steel, so maybe we can try and. By the way, good evening, everybody.
Good
Pardon my
evening.
manners. Yeah. So I was considering that we have a look at modeling of a concrete structure. I know we did some modeling of some concrete stub columns.
Mm.
That structure did it have some foundation ground beams or not?
No, it didn't have any great beams.
Yeah. So we'll look at modeling of entirely concrete structures, concrete elements for a concrete structure.
Okay.
Yeah. Then if we get more time, we can even look at some other structure like a retaining wall,
Mm.
how it's modeled and the kind of forces that are at play in the retaining wall, and some of uh, the like the tricks of analyzing as well as some of the components that you need to include when you're doing a retaining wall.
Mm.
Yeah.
So
So, however, we'll start with the concrete structure.
I
So
didn't
maybe
want
a
to put
maybe maybe two or three stories building. You said
I didn't want to put my foot in my mouth and say something wrong. So this retaining wall, is it something that you've done with the consultancy firm, or is something that you've just done an analysis on?
yes. I have. Well, I had the opportunity
Because I
to
do not want
design
to
a
say
retaining
something
wall
that that can
for.
incriminate.
I had the opportunity to design a retaining wall for uh, a recent project that is actually being constructed right now. It's the Nakonde border post. So it's Zambia, Tanzania, the border post. Yes.
Each.
Ah, senior citizens in Mwebo, yeah. So there's a retaining wall that we did there. It's 233 meters long. So you can't do a concrete structure that is spanning all that long. So we had to do it in panels. The maximum length was 10 meters.
For each panel.
So each panel, yes.
What would happen
So
if you just cast? Anyway, there wouldn't be enough concrete and like this. But what would, hypothetically speaking, what would happen if we casted it all at once?
all at once, there'll be one of the problems that we'll have, a very, very common problem, is expansion.
Okay.
Yes. But the most, I think, something that can pose difficulty in construction is that any structure will have to have some construction joints somewhere. You can't go 233 meters, they're just pouring, pouring, pouring. You're going to have uh, a probability of having some cold joints somewhere. So you want to terminate structures. Uh, like you and I were at the King's Hospital. You know how that King's Hospital had like 25 meters max. You have to terminate. You have to have a construction joint. So the whole entire building, was it 450 something, 450 meters, something like that. The basement had to be cut in panels of like 25 meters max, 25 meters max. Why? Because you have to first of all have a construction joint somewhere where you can treat this part of the building as an isolated component from the others. And also that construction joint can also serve as a expansion joint. Concrete structures expand, these are solids. So as they are expanding, due to temperature fluctuations and so on and so forth, you want to give them an allowance to be able to change dimension and come back to normal. I don't know. Am I audible?
Yes, you are.
Hello? Yes.
Yes, you're very audible.
Yes. So reasons why we can't do a 203 meters or continuous is because it's not feasible. It's not workable, and unless you say you want to behave like uh maybe okay, if you're going to like mobilize maybe 100 concrete mixers, that's from the undertaking point of view. 100 maybe concrete pumps, I mean, not mixers, concrete pumps, and concrete is flowing in rapidly, so you're able to pour the whole thing monolithically. But other than just undertaking, you want to also consider expansion, and so that's one of the key reasons why we terminate the building.
That is one. I've got some questions. That is so you can go first.
Yeah, so I was going to, by the way, I wanted to show some photography
Hey, you
of
can you can show
do I
if you want.
have?
Mr. Mundia, I just have a question.
Yes,
Just a
sir.
quick. Okay, so I remember at the King's Hospital,
Yes,
we we had what we used to call the expansion joints.
Mm.
yes,
Yes, I think it was at the after maybe 20 meters. Yes, if I can remember
yes,
very. Mm.
yes.
So now you are mentioning of construction joints. So I just wanted to find out what's the difference between the expansion joint and the construction joint. Because from what I heard at the King's Hospital, because Mr. Mike was like my supervisor there, he said the expansion joints, they are for thermal expansion due
Uh-huh.
to weather fluctuations. Yeah. So what's the difference between expansion joint and construction joints? Thank
Great. That's a very good question. So, construction joint, from the name itself, uh, it's uh, it's a joint that is intentionally made for purposes of making construction easy. Okay, making it easy in what sense? You are doing something that is continuous. Say you're going to be doing maybe a building that is spanning in length maybe for 100 meters. You won't pour concrete over 100 meters at the same time. Like you're just pouring, you're just pouring, you're just
It's too
pouring.
much
You
concrete.
want to terminate it. You say you pour, you terminate to a point where you can allow that concrete to actually uh, be worked and it sets. Then you continue. Have you noticed that when you are doing, if anyone has ever been where we are doing a slab,
Give him the
okay,
actually not to
even
interrupt
just
you.
for residential purposes, you find that by a slab, I mean like a concrete floor, a slab on grade, that is a concrete floor, like maybe you're building a house. That thing we call slab, like the ground floor. You want to aim, you say, okay, today we're just going to pour
You see here.
maybe 10 meters by 20 meters. So at the point where you're deciding to end, that's a construction joint.
You guys can
Okay?
hear me.
Yes, yes, I can hear you.
There's
you.
actually the simplest example is a kicker for columns. That's a construction joint.
Yes.
But carry on, Mundi. Oh, sorry. Yeah, it is a
Yeah.
construction joint.
So yeah, it is a construction joint. So the construction joint is basically you want to do an undertaking and have it terminate somewhere, then you will continue. So it's like you are phasing. It's a way of phasing a continuous process of construction without. So you know that concrete, the hydration process of concrete, it's within a short window. So in an event that you are undertaking construction continuously, then you find there's an interruption somewhere. You have a potential of having a what is called a chord joint. Now that's what we avoid having. That's why we actually do construction joint. So we say, okay, let's plan to be able to cast 100 cubic meters of concrete.
That is
So
true.
that 100 cubic meters, you want to lay it now in 2D. Cubic meters, it's in cubic meters, it's a volume. So you say, okay, how much space will it cover? Now let's apportion this place and pour that concrete. Then tomorrow we'll do another 100 cubic meters. So at the point where you decide to terminate, to say this 100 cubic meters will end here, these are the boundaries of it. What you have as the end, which will be a continuation tomorrow, that's a construction joint.
Correct.
Now, an expansion joint, on the other hand, is usually why these things work hand in hand is, you know that where you have ended today, you are going to continue from that point tomorrow. Now, remember that when concrete is heated, or the temperature of that concrete rises, it begins to expand. It's like solids, chemistry. Solids, they expand at high temperature and they contract as the temperature reduces. Yeah. So at the point where you decided to do a construction joint, while we are continuing, you want to leave a space, or that space now is what you will call now an expansion joint. Now remember, construction joint was just termination. Now after you have terminated, what do you do as you are continuing? You want to leave an allowance for expansion so that you don't have cracks. You allow the building to expand and contract without affecting the other part of the building. A simple example I can also give before we take too much time and chew the time for the class is the offense. When you're building an offense, you do it in panels. You know, you want to do your panels like 2.5 meters. At the point where you're terminating, you say, the bricklayer say, zachache panel imos. Where they have stopped, that's a construction joint. Now, the fact that they leave a 10 millimeter space, now that's to allow for expansion now. That's an expansion joint. So you find that the same space can be called construction joint and can be called expansion joint, but the meanings are different. Construction joint is to phase your works. Expansion joint is to allow for one part of the building to be able to expand and contract without affecting the other part of the building.
Okay, so just to add on what Mundia has talked about, in addition to the having the expansion joint to have that to allow the structure to expand, another purpose of the construction joint, if you are building, for example, a very long structure like a bridge, and also maybe if you've got a very high building which is very wide, like a retaining wall, in an event of maybe instability or say differential settlement, you want,
Yes.
if one part is going to collapse, you do not want all of it to collapse. So you'd much rather
Mm.
one part collapses, the other one remains intact. But if there wasn't any
Yeah.
expansion joint, all of it would fall.
Mm.
So, in addition to thermal expansion, the other purpose of the expansion joint is structure stability, so that you can have different parts.
Yeah.
Also, while we are talking about joints, you might want to talk about the socket joints in the slab on grades, the foundations that Mundia talked about, and also the crack
Yes.
control joints in plasters, and also there
Yes.
in the foundation slabs. Daddy, so you had a question. Do you still want to ask before we start the class?
I know it's already passed. It was actually just a contribution. And then he mentioned something related to it. He was talking about heat of hydration. Why you can't have a large pour at once. So you have high heat of hydration, meaning yeah, to reduce even your strength of your cement when you pour like that
Yes.
because too much heat.
Mm.
Uh, okay. In that particular case, then let's see. We can start the class. Do you guys have any questions from yesterday's analysis? And I didn't actually have time to research on that error code. Usually, when we're using these softwares, there's that problem with runtime. The runtime. So if you guys do not have any questions regarding that aspect, we can carry on. So should we carry on, or are there any questions? Hello. Hi. Can you stage
I have
260,
a
please?
question. Hello, can you get me?
Yeah, we can get you.
Yeah, good evening, everyone.
Good evening. How are you?
I'm okay, thank you. How are you?
You said hello.
Regarding
Hey, boss, I'm
the
quick
structure that we were
Brian.
trying to analyze yesterday, the steps that were taken following what you were doing failed to be analyzed. So, like, what steps are you taking to try and help us analyze the things on our own? Because I remember you opened another document for you to analyze it. So I just want a bit of clarity on that.
Okay, first call. First, I've just muted my microphone. Call or Chim. Okay. Sorry guys, I was on a call. You said?
I was saying the structure that we're trying to analyze yesterday. Yes, the previous one. I remember you had to close the one that we were actually doing step by step, then you opened a different one, which was the same.
Yeah.
Yeah, I tried to analyze it on my own. It was just so I wanted a bit of guidance on how I can correct something in there.
You said you are trying to analyze and then
I was getting errors.
An error message.
Yes. So I managed to correct that error message in the pre-analysis. Then I tried to run the thing. It told me the error it gave me was just it said the members listed above are either fully unsupported or supported by beams stroke slabs. So these are the columns on the fourth floor. On the fourth story. Yeah.
That one is
so partially. Like if you know what causes this type of error, maybe you can do it for us.
Okay. Usually you can run that you can run the analysis like that and it will pass. But the error message that you cannot actually just do anything about is the one that we encountered yesterday, the runtime error.
Okay.
So did you get past that runtime error and did it give you an output?
Yes, I got. Yes, after I went through the runtime error, the first time I went through the runtime error, I closed the program and opened it again. Then I changed a few things so that the pre-analysis had no errors. Then I ran it. Then it gave me something about transfer columns and the same message I could from reading.
Yeah. But after that, did you go to that design status and did it show you the colors?
No, I didn't do that part.
Okay, so right now, if you can open your Prota, I hope you can see my screen.
Yes, I can.
So there's this tab here. It says Active Windows Settings and Visual Interrogation.
Yes, yes.
So when you click on it, and then you go, it starts with Visual Interrogation, Entity, what animation or controls. When you go to Design here, when you select or deselect, it will either be there or it won't. So for example, for this one, you can close it. When you click on none and you say okay, it disappears. And then to get your design status, you click on it, you go to design here, design status, you click on it and you have this table here. So can you try to do that and see if it comes?
Let me try and do that. So I'm supposed to click an independent component, then I click the geo thing.
What do you mean click an independent component?
Like, am I supposed to click like maybe a theme on its own? Then
No,
I
no, no.
click
You
this
actually do
view.
not need to click any member. Just
Okay.
yeah, just click the button and then go to design and click on design status without clicking on any member.
Okay. Yeah, I've gotten for the stub columns. It's showing me that the analysis is expired.
Can you share? Can you share the screen? Are you able to share screen?
My I'm using my phone for this video.
Oh.
I'm running.
Or maybe can you send pictures into the chat or WhatsApp?
Yeah, I'll send some pictures, but yeah, for now let's carry on the class. I'll send pictures to you. Yeah.
Okay. All right, I hear you.
Thank
So if it gives you a design, an expired analysis, what that means is that you made changes. So for example, here, if I, or if you delete something, for example, if I click on my column and I press, or my, yeah, and I press delete here, it's not deleting.
okay. I can't see your screen, sorry.
Oh, I stopped sharing, sorry. When I click on share there, hopefully you can see it now. If I go to my plan view and I go to where we were placing the columns from, if I select a column and I delete, it gives me this warning. It says the following analysis results will be invalidated if you proceed. So if I proceed, it will take me to the expired analysis and all the members will be orange. For example, if I say yes, I go back to my 3D, you see, all of them are orange, meaning it's expired because of that change. If I control Z, I can rerun my analysis and then it will give me these colors of either fail or warning or okay, like that. Analysis, building analysis. It first says analysis, perform a building check. Chimba sosende motoka. Yeah. Mungu Road, kwa Mount Meru. Ask him to take you to Toto in Mungu Road near the roundabout. Toto Energies. Zam Leather. Tamkwishi Zam Leather. Not Zam Beef, Zam Leather. Yeah, ask him to drop you there at the Toto. Ask him to drop you at the Toto Energies filling station where there's the Bonias. Chimba will come and get you from there. Okay. Wanaisha hapo mnomlia kaka road. I don't trust you. Okay. So you guys can see the screen, right? I don't know some of the. So I'll start analyzing. Yeah, the
Yes, yes,
building mode
yes.
option must be checked.
Hmm. On my
Oh,
end, it's not busy. Maybe it's an issue of network.
okay. So after having done that, deleted that one column, you can see that now we are back to normal after having run the analysis. You can see that we are where we had started and then we just have these other few columns that we need to design and change, you see. So now in this video, to make it short, we've had a lot of discussions. What we can do is we can go to Prota Steel, and then we can solve some of those problems that Nisa was talking about. So if you go to Prota Steel there, it will load, it will give you this window. Because this most of the connections, unlike Revit, you have to put them manually. But if you've got like maybe 2020 or 2022, there's a thing called interactive combination, I think, where when you select the whole structure, you right click, it will choose the best connection details for you. It's very fast and it's far much easier. But for this one, we'll just have to do it manually. So here it gives you this report information. It tells you 330 profiles successfully imported, played successfully, grid successfully, and then some of these error messages: imported frame ID, plain what you cancel, and then you have that, right? So before you can actually use ProtaSteel, you need basic information or basic knowledge on how connections work. For example, you might have an end plate, so you need to know what an end plate is. An end plate will be that 20 millimeter or whatever millimeter or 16 millimeter, might be cast iron or wrought iron, and it will sit there, it will hold down the anchor bolts, and then it works so much so that you can weld your steel column to the plate, because there aren't many ways in which you can connect your steel column to the concrete. So you'd have to have steel and steel connect. Steel and concrete connection. Usually, you need to introduce another metal, another steel. Works for pad stones. It works for. Someone is asking to join. Yes, so it works for pad stones. It works for these other members. And then another connection that you'd want to use is the column to beam connection. Since both of these are steel, you can introduce welds, which can either be 6 millimeters, or you can introduce uh, boats, where you introduce boats where you have hose. It can be maybe a 16 or 18 hole, and then you use a 16 or 18 use a 16 or 18 an anchor boat. And then another detail would be here, where maybe you need to have a haunch, and also here and here, so that they can support each other properly. So the simplest one is the haunch detail, because what you need to do here, you've got all these connections and stairs. Sometimes when you hover over them, they will give you information like this is a stringer for a staircase, a steel staircase. But personally, where I want to go is here. You see, it tells me fitting connection, and it shows me. Actually, this is not for the haunch. This is for. It can work for the haunch, but it's not preferred. The haunch detail will be. Let me just look for it. I think this one is for the size. So okay, let's try for this one. So you select two. You select this. You hold Shift, select this, then you right click. Oh, that's for Revit. Sorry. So you go to this, you escape, you choose this option like that, and then you click that and that. So here it says unsupported orientation. So the connection here isn't that one. You'd have to use maybe something like, okay, let me show you for the ones that I've actually used before. Okay, let me start from the, even this one can work. This one here. So you select that one and that one. So there, this, this, and this. Anyway, let me start from the base plate. You go to this, you select it, you select this, and then you have something like that. That's one way. The other way, you can draw the plate yourself. Okay, so here you can put this anchor, the anchor bolt. When you click on it, you have an option of that little cursor. So you have to select the edges. You select there and there. You have to go back into the forum. But these are not proper, guys. You have to forgive me. When you cancel out, you spin. You select it. You move out of the command so that you can have it properly. Okay, so now you move in, you click, and so on and so forth. But let me show you a different one where you can actually draw the base plate. Okay, let's try this one for these end supports. You click here and here. It didn't show. Ah. Okay, another support that you can have is the beam to the channel. Actually, so that support. Profile fit. Let's go down. Let me just go over them quickly. Okay, this one is a purling to get connection. You press on it, you select this one and this one. So you have something like that. So usually this will depend on also your selection method. And this one is not the best. Let me try to do that once again. Where was it? It's here. I'll press this and this and enter. Yeah, this is more like it. You can see here, although it's inside, we needed it outside. Alternatively, you can select it and then you modify it. Set view properties, the work plane. Let's try another one where we select this one and this one. You right click. This one has given a similar situation to the first one. Okay. This one and this one. You right click. Also given that similar situation. this one and this one. You right click. Okay. If you've got any suspenders, you can use that one. Okay, so this is the plate function. When you click on it, you can go maybe to this, and then you have to select 4 points. One there, another there. You move. You have another one there. Alternatively, you can work in 2D. You select the corner there, and finally you finish the loop here, and then you have a plate like that. When you exit out of it, you have to click there, and then you can put your anchor. But that's not the perfect. Yeah. Start groups. Okay, so when you are done, you can export this by going in the manager and creating an assembly. So you would have to select all of it like that. When it becomes red, you right click, you go to create drawings, and you click on assembly drawing. And then here, when you see it says to create, open, or manage drawings, you either press F6 or double click the drawings manager. When you double click it, when they are not ticked like that, you cannot produce any drawings. So you'd have to tick them all. Like this, I need to delete it. And then you can export here, or you can print. But the prints there, they're not as, if you've got a printer connected, you can print. If not, you'd have to export into a DWG. And then you select, when you select the assembly, you say oh, right? And then you can export. You select your destination folder. For example, since we're working in the here in the 30 days, you go to this, and then you command the correct one. Okay, desktop. Okay, in here, teaching material, 21 days, you can click the reports, and then it starts exporting like that. So here it shows you that it's done. You click on it, and then also you can go in concrete. For the concrete, you go to load properties, Prota details. When you click on it, I hope it doesn't disconnect. Okay. When it Prota details is essentially for a lot of concrete. Prota steel is for all those steel assemblies and connection details. So when you go into your Prota details here, you can start by creating a new one, or you can generate an automatic. Personally, I would recommend that you start by creating your own. And then when you enter, it's got all these sides, the forms, the column applications, the column elevations, and the pads. So when you click on it, first you left click, and then you right click, it will tell you draw forms. And then here you can change the parameters accordingly. You can insert on a table, you can, so suppose you do not insert on a table, you draw. This will be how it, this is how it's going to look like that. It should have given us all the bad bases, but remember in here I deleted some, so it's only shown us some of them here. And then it also gives us the foundation slab, right? And then here, if you would like to create these reinforcement details, you would have to go in your Prota, and then you go to the first floor. For example, you do not want any rebar. Maybe you just want Conforce 257 here on the ground floor. Remember, according to the session from last time, this one, if it's got very little reinforcement, it's okay because it's not suspended, and also it's on the ground. So usually you just add a 193 or 257 according to the use. But for this one, the suspended one, it will require reinforcement. So what you do, in order for it to show you, you go to the plan view, you change your view, you go to the plan view, and then you go to the first floor. You see mine already has this information, but how you create this is, okay, let me see if I can delete one. You see, no, you you delete this the strips. They are called slab strips. So you see this one doesn't have information, and I'm pretty sure that's the way that everyone else is. So what you do, you go to this option here. It says slab strip. When you click on it, when you run it from one end to while holding control, one end to another while holding control, it will give you the reinforcement in the y direction. There, it says y tens 250 spaced at 250 T1, meaning T at the top, right? And bottom. But remember, this is only for the y direction. For the x direction, you go like that, you click, holding control, it selects, you see. If you want double cage or you want single cage. A single meaning it will only be top, bottom in the y direction. Double, it will be both in the x and the y direction like that. So that's how this is it's how this output comes. If you just send it like that without having done the slab strips, you won't have any reinforcement details like that. And then there it gives you a bar bending schedule accordingly, the cut length, the total kgs for this particular, and it shows you the number of rebar diameter sizes it uses. Okay, so that's for the form plans. Let's see if it's not okay. So for the column elevations, you do the same. You select, right click, you draw column. You draw, or you press draw, then you click. And then it will give you column elevations for the stubs. It will not give you column elevations for the steel. The steel column elevations, you'd have to go to Prota Steel. That's where you get them. But for this one, it shows you these column sections. Yeah, for concrete. It shows you the bar size, the cut length. Here it will only show you the type of sections that you use for steel. But an elevation, it will not show you. Oh, column elevations are here. These are sections. So let me just right click there, draw column elevations. It's going to look like this. Aha. It will give you the depths. So here it tells us that it goes from 0 up until 1.3. This is your stub length before creating that 200 step. And then depending on how you designed your footings, you would add the thickness of the footing. What I mean is, for example, here you can also draw the column schedules, but the column schedules will be something like the cross sections here, so you can put it somewhere here. So it just gives you the schedules of the columns. If they are similar ones, for example this one, so it says 1C3 and 1C4 are the same, and it will only output one like that. It also shows you the grid line, the axis. and also where it's situated, right? However, for the footing, you go to draw pad foundations. You click on draw, and then you press, and then you remember I only use three types in this video. I only used I think 2.6, 2.5, 1.7, and 1.5. So it will show the quantities here. The bar mark, the sizes, I used 16s. Oh, also only because there are only three here. If I go to my 3D, let's count them. Yeah, actually, 1, 2, 3, 4, 5. Yeah, but two are the same. I think some of them were combined. These were grouped. So when you right click, it shows that they're in a group. So if you once you finish that, you can send them to AutoCAD to clean them, either clean them, or you can print directly from Prota details. So how you can print directly from Prota, you can see that all of them are, when you click like that, all of them are ticked, meaning they've been printed here, except for the steel, which you need to output in Prota steel. I can show you how to do the elevations in Prota steel at a later time. So here you can either decide to draw when you click on the print option here, or when you go to file here and select print, it will give you this page, and then you can modify it. Personally, I do not put my sheets here because I think that the largest sheet size that you can use is A3, and for council submissions you probably need like an A1 if you're working for a consultancy firm. And then here you would say the whole, either the window or the extent or the whole, scale to fit, and so on and so forth. But personally, I do not. You can also put it in landscape or portrait. Here it says partial. You have to change it to full. Or actually, full will give us all the. You can use full, but use a window, and then you pick the one that you want to choose, like that. Instead of it printing the whole thing, it will print this view only in particular. And then you can either print in grayscale, meaning just black and white, and then you can also put it, I think you can put it on the center to paper, like that. It will sit there. And then when you click on print, you can select where you want the destination folder. For me, all of these files have been putting them on the desktop, and so therefore I'll go on the desktop in a folder that says 25 March Madness, teaching material, 31 days, and then I can add a folder and say drawings, and then I'll save it as one, or I can say foundations, uh, foundation bases, like that. And then I can go here. Where is it? It was on the desktop. 25 teaching material 31 days. Here in the drawings I'll find it. And then if you're comfortable with the way that it is like this, you can share it like this. For me personally, I would recommend you have your own template and then you send to AutoCAD. So how you send to AutoCAD is you, in fact, let me have a folder here that says DWGs. How you export to and import to AutoCAD, you have all this information and you say export drawing. Here it says export. You choose the type of export and what file format you want to use. When you say DWG, you can it automatically saves in the Prota file in the documents. If you want to change it to go to a different directory and also give it a different name, you can do that. So if you say open directory, you can see that it goes to this. It goes to Prota 2018 documents like that. You see in this PC. But what you can do if you wish to change, you click the change and then you go to desktop and then you say you find, where is it, 25 March Madness. I couldn't see it. This one here. You select, you go to teaching material like that, you say DWGs, and then you say okay. If you wish to change the name, you can change it. I'll maintain it like that and I'll export. Here there's a command thing that loads up and finishes. When it finishes like that, you can double click, you go to your AutoCAD, and then from AutoCAD you can place it on layouts. So for example, if I would like this one to say 100, or like it to say foundation bases, I can change like that. And then here I can give it now an A3. You go to page setup, you can modify this sheet size. For me, I want to use high quality AutoCAD, and then I want to use the ISO A1 sheet like that. I'll print in monochrome, and then here I want to put it on the layout, and then when I okay, you can see that the page changes. But then how about if I would like a title block? What I can do, I can either import from template, or if you've created a title block of your own, you can select it. However, AutoCAD comes with some templates there. For example, this is for an architectural template, and then these are imperial. M is metric, I is imperial. So for me, I'll choose an ISO. Maybe an ISO one would be a standard one. Okay, maybe I can preview. This one actually, the imperial architecture one looks okay, but the metric architecture one just has like a very simple title block. Okay, suppose I wanted to use this one. I do not want to use mine. I do not want to use mine. So you click and then use OK it. It comes like that. You confirm the paper size uh, here in page setup. Is it still recording? Okay, it is. So here you modify it. You say you see it in arc. You say I want an A1 like that, and then I want to print high quality and monochrome in landscape. You preview. You see some of it is cut in that side, meaning it's out. But for this video's purposes, you see it's out. If you like, you can scale it. There is this trick that I use. You select everything, you go to home, you scale it like that, and then you do that, you estimate so that it can be within, and then you move. Although I still feel as if it's too much. You move it to the corner, you select like that, so that everything can be inside. Okay, now everything is inside. Yeah. When you print preview it, when you click on the print, you preview, nothing is cut now, you see. Everything is within the boundaries. So after having done that, did it just ask me? Here we've got a layout view, the viewport. When you click inside the viewport, it's locked there. So you unlock it, then you zoom out, and then you can change what scale you want. In fact, you can have two sheets if you like, two drawings like that. Okay, I'll put it here. This is good. And then I'll move the other things. Let me just move this downwards. Still recording? Okay. Select move. I want to move in 90 degrees. I constrain it like that. I select, and then Also this, I want to move it. Oh no, what I was supposed to move is just this. I want two. Okay, like that. And then I'll move these. So you can play with them according to the way the presentation. Now it's just about presentation now. If you see, sometimes the dimensions will overlap, so you need to check them. Okay, in this particular situation, everything is neat. One time I had Mundia call me because they were too thick, right? Mundia, remember? Okay,
I,
so
I, I remember. Line work.
yeah, so now it's basically about presentation. You move that, you go there, and now you see you can have this on one sheet. You have the foundation, you have what? If you like, you can name them. You create some text, you say foundation bases. When it's too small, you select, you click on properties, you increase the text height maybe to 200. Too small, you go to 1000. Now it's big. And then if you like, you can make it bold, whatever, but we'll maintain that. So you see, so now when you print, you click on print, you preview, and you have that sheet, and then you can now print it. Save it in your wherever your destination where you're keeping these files. uh, PDFs. No, PDF. So now it's presentation time. You will say PDF, and then you can give it a name, maybe foundation basis, like that. And then this will be your presentation. And then if you'd like to go in and change the maybe the person that designed it, or the person that checked it, you can change if it's got a title. So this one was imported as a block. So to edit a block, you'd have to export it, and then you can give it a name, maybe proposed construction of whatever, of whatever the name, the revision, the date, and also a project name, the sheet, and so on and so forth. So I'll share this the print just now so that you can use it as reference. Um, on the desktop. I think this is it. If you've got any questions, guys, you can either send them through on WhatsApp, or you can ask now. The loading of Prota still? Oh, it's cut. Oh, oh yeah. There's that also, right? Mm, oh, there's already a person that wants to join. One more thing. Okay, so that was it, guys. We shared the sample. I hope that you can be able to do the same thing and you can share in the group. Paul, are there any questions?
No questions for me, Mr. Show.
Oh, I don't know if these people will come back, but I think
I'm not.
we can end the session right here. Oh, someone Nisa is here. Okay, yeah, Nisa, you've did you follow through?
Yes, I did, but I'll just have to watch the video to do it on my own.
Oh, okay, that is it. That is so. Do you have any questions from today's session? Were you able to follow through?
Uh, I'll need to watch the previous ones as well, but I think I followed. But even though the network was a bit slow, so
Okay,
I'll just have to watch the upload.
okay, you can rewatch the. Okay, guys. So if there aren't any questions, then oh, another thing Obi was asking because we didn't load the foundations because those edges maybe they'll need some blocks. The edge beams when you start partitioning or closing off. Since this is just a skeleton, if you're going to build blocks on top of those beams, you can load them. So I don't know if it's something that we can do in the next video or we can wait to we can move to a different structure and see how Mundi is going to do. Hmm? Maybe we can do it later. Oh, yeah, yeah. Okay, guys, if there aren't any more questions, we can end the video here so that it's not too long and then you'll be able to rewatch. If from watching videos you have any questions, you can send them in the WhatsApp group or you can comment or you can send an email. Alright, guys. Stop recording. Yes, studio.